So we're going to talk about glycogen now, which is a pretty important storage form of glucose. And so our brain and our red blood cells rely mostly on glucose, and we'll see how maybe the brain can rely on something else later on in our lectures. But glucose is the key here. That's the preferred energy source for the brain, for red blood cells, and also for our muscles. And so, after we eat a meal, glucose is pretty abundant because we've, broken down our foods into glucose. And it's wise to store that away for later usage. And so we can convert that into glycogen, and that's stored in both the liver and the skeletal muscles in pretty large quantities. And so for most of us, if we don't have diabetes, if we're fasting, so meaning we've had, 8 to 12 hours or so without a meal, our blood glucose levels are generally less than 5 millimolar, but the units that you're probably used to, if you've looked at blood glucose levels, are in units of mgs per deciliter or milligrams per deciliter, which is, somebody without diabetes or pre-diabetic would have that somewhere in the range of less than 90 mgs per deciliter. And so once, the blood glucose levels start dropping, the body needs to keep blood glucose levels up, and one of the first things it can do is to break down that glycogen to maintain that blood glucose supply, to keep the brain fed, to keep the red blood cells fed, and also the muscles. So what I want to do is think about this molecule glucose 6-phosphate, right? This is that first intermediate that's made, the product of hexokinase during glycolysis. And it turns out that this molecule actually is involved in lots of things. It's kind of a hub in some ways, or a central metabolite, meaning that a lot of things are feeding into it. So we're going to create this figure in this video, and we're going to add to it as we go on and learn other things. But this is going to be kind of a roadmap that we're going to use. So let's put that up here because I'm going to refer to this as a roadmap as we go on for how these pathways are linked together. So somewhere in the upper 2/3 or so, write a G6P to represent glucose 6-phosphate like this. And let's first think about and back up and think about the knowledge we already have of glucose 6-phosphate, and that is its role in glycolysis and how it's actually made from glucose. So I'm going to say glucose can be converted into glucose 6-phosphate, and that's carried out by the enzyme hexokinase. And now that's going to end up costing us an ATP, right, as we have seen. And now, if we think about the rest of the glycolysis pathway, I'm going to draw that going straight down like this. And remember, for every 1 glucose that enters glycolysis, we get 2 pyruvate molecules. So I'll write that here. And just thinking about where along the pathway we are gaining and losing ATP molecules, we can sort of think about that as well. So remember, after glucose 6-phosphate is made, then we have, there's an isomerase, but then importantly we have the phosphofructokinase enzyme, PFK, that is going to also lose or consume 1 ATP molecule. And let me sneak a 1 in up here above hexokinase, just to be sure we're counting things carefully. And then remember that later on in the glycolytic pathway, after aldolase things split up, we make some additional ATP, so we have a net gain of ATP. So one of those is the phosphoglycerate kinase, PGK, and the other one is the final step there, that is the pyruvate kinase. And in both cases, each of those, because we've doubled the number of molecules after aldolase, right, we get 2 ATP at each of those steps. And so this way that we have it drawn here, and let's just label this side glycolysis. This way we have it drawn here, we can really start to think about ATP yield. And we can see now that, oh yeah, for every glucose that enters, I'm going to have a -1 and then another -1, so a -2 ATP. But then as I continue on to pyruvate, I get a +2 ATP. So after this stage, we're kind of at a net 0. But then finally, we have the pyruvate kinase step, and that gives us our net 2 ATP. So we're going to end up using this map to explore various pathways. And so the next pathway that we're going to look at, like I've mentioned here, is glycogen. And so we're going to add something to the top here. We're going to have an arrow going up to glycogen, because guess what? Glucose 6-phosphate is the form, more or less, that is used to make glycogen, and then glycogen can be broken back down to get glucose 6-phosphate when energy is needed. So just to be clear what these pathways are, we have the glycogen synthesis is the making of glycogen from glucose 6-phosphate. And then we have the breakdown of glycogen, which we could call glycogen degradation, or the fancy term is glycogenolysis. And don't get that confused with glycolysis. These are different processes. And what we'll do in the next video is explore these pathways a little bit more.